So welcome back, Level 2 NCEA Chemists, continuing on with organic chemistry, this time looking at the alkenes. Okay, so before we actually look at the alkenes, let's get some key terms out the way. So saturated hydrocarbons are hydrocarbons that contain no double or triple bonds, which are the alkanes we saw in the last video, only carbon, hydrogen, single bonds. Whereas unsaturated hydrocarbons are ones that contain either double bonds or triple bonds. And today, we're going to look at the ones that contain double bonds, the alkenes. And the alkenes can undergo addition reactions, and that is where one atom is added to the alkene to form an alkane. Okay, cracking is used in industry, petroleum industry, where bigger hydrocarbons are broken down into smaller ones. An elimination reaction is where an atom is removed from an alkane to make an alkene. Geometric isomers are ones which have the same structural formula, but a different arrangement of the groups around the double bond. And finally, Markovnikov's rule is where the carbon with the most hydrogens in the alkene gets the hydrogen in an addition reaction with a HX, where X is a halogen. So, alkenes. So the class name is the alkenes. The general formula is CnH2n, where N is the number of carbons. The functional group name is the alkenyl, and the functional group is the carbon-carbon double bond, which we see there. And the suffix is the -ene, hence they're called alkenes. So these are the first 7 alkenes. So using the same numbering system as you would with the alkanes, except you can't have methane because you need a carbon-carbon double bond, so you need at least 2 carbons. So ethene is the alkene with 2 carbons, propene 3, butene 4, pentene 5, hexene 6, and heptene is 7. So in terms of naming an alkene, okay, so you select the longest carbon chain containing double bond and number that chain from the end, okay, place the ending "-ene" at the end of the name and use the number to indicate the position of the first carbon in the carbon-carbon single bond. As in alkanes, you then prefix with substituents like alkyl, ethyl, or methyl, or propyl. And then the side chain position is based on the number of allocated from the first carbon in the carbon-carbon double bond. Okay, so looking at the example we have on the right, the longest chain is 1, 2, 3 carbons. Okay, so it will be propene. And the methyl group is on the second carbon, because the first carbon is where the double bond starts. So it will be 2-methyl propene. So in terms of structural isomerism, you can have different structures due to either different positions in the double bond, okay, so double bond can move, or in terms of branching. Okay, so in the first example right at the top, the double bond is going to be in the first carbon, so that's just simply 1, 2, 3, 4, 5, longest chain, so it's pentene. Whereas you can see in the one directly below it, at the bottom there, you can see that the second carbon now has a double bond, so it's still pentene, but it's pent-2-ene, illustrating that the second carbon now has the double bond. And then for the branching, as you see in the third example on the left, so again you have the longest chain is 1, 2, 3, 4, so butene, but starting with the double bond being on the first carbon, that means the methyl group is on the third carbon, so it will be 3-methylbutene. So you can also get geometric isomerism with alkenes, okay, because the carbon-carbon single bond can rotate, so you can have the hydrogens either on the opposite side or the same side. So if the hydrogens are on the same side, we call that cis, okay, which you see on the example on the left. And if they are on the opposite side, then they're known as trans. Okay, so that's trans to pentene as opposed to cis to pentene. Moving along, there's a number of reactions that alkenes can undergo. Okay, so alkenes can add bromine across the double bond to make a dibromo alkane. Okay, and you'll see a color change because bromine is a brown color and the dibromoalkane is colourless. So it's a test to see if the compound actually has a double bond, because an alkane will not do that unless it's owned for a long time and it has UV radiation. Okay, so adding bromine water to an alkene will decolorize it. Then we have the reaction with potassium permanganate. So again, an alkane will not do this reaction, whereas an alkene will react with acidified potassium permanganate to make a colourless diol. Okay, we'll look at alcohols furthermore in a later lesson as well. So just have to know that there's an addition reaction which forms a diol which is colourless. So it's another test to see if you've got a saturated or an unsaturated compound. Unsaturated compounds will undergo this reaction. And then we have the addition of hydrogen to an alkene. Okay, so ethene, okay, ethylene is a generic name, so ethene is the correct name, will react with hydrogen with a platinum catalyst, or maybe a nickel catalyst, to form an alkane. That's essentially how your margarine is made. So the unsaturated plant oils get hydrogenated. Hydrogen is added to make saturated butter, basically. Saturated fats. And then we have addition of water to alkene, so under forcing conditions, so high temperature and high pressure, and also acid catalyst. Ethene will react with water to form an alcohol. Okay, so that's another way you can form an alcohol, and again we'll look at that in a later video when we're looking at the alcohols. So in terms of addition of an HX to an alkene, you'll see it makes a haloalkane, okay, and the chlorine is only substituted on one of the carbons, not two, as we had in the case of bromine. And that's where Markovnikov's rule comes in. That's where the rich get richer. Okay, so what's that basically saying is that the carbon on the double bond with the most hydrogens will get the other hydrogen, and the carbon with the least number of hydrogens will get the halogen, okay, which you see there in the visualization on the slide. Then we have an elimination reaction. So in that, under forcing conditions, so a very strong alkali and ethanol, refluxing and heating it, the halogen is removed and it goes from an haloalkane to an alkene. A double bond is formed through an elimination reaction. Then we have polymers. Okay, so polymers alkenes can react to form a long chain polyalkenes known as polymers. Okay, so the monomers are going to be the alkene and the polymers will be known as the polymer. Okay, so ethene forms, for example, polyethene in the form of a repeating unit. So monomers and repeating units. So in addition, polymers repeat unit is found simply by removing the double bond, adding the single bonds across the square brackets, as you can see there, and we use N because N is a very large number for polymers, so it can be up to like 1,000 or even 1,000,000. Okay, and to go backwards, what you do is you remove the square brackets, remove the single bonds, and add in the double bond again to go backwards. So these are the types of polymers that you need to know. So the top one there is tetrafluoroethene, or PTFE, commonly known as Teflon, and that's used for anti-stick coatings and frying pans and also on your clothes like Gore-Tex. Then we have chloroethene, okay, and that's known also as PVC, and that's used polyvinyl chloride as its generic name, PVC, and that is forming pipes. Ethene is going to form polyethene, which is used for plastic bags, and propene is used for polypropene, which is used for thermal underwear and things like that, co-garments and fashion. Okay, then we also have cracking in the hydrocarbon industry. That's when you get like long chain crude oil, basically. You heat it with a catalyst, and it breaks it down into smaller alkenes and alkanes, which can be utilized in industry. So here we have ethene and propene and a long chain alkane, which can be used as a fuel in terms of petrol. Okay, so in summary, alkenes can undergo addition reactions to form dihalogen alkanes and halogen alkanes, addition reactions to form alkanes with hydrogen, added across the double bond, addition polymers, and also water can be added to form alcohols as a summary.